Welcome to quicktechie.com, Palo Alto Networks, Network Security Generalist Certification Training. Let's dive into next module.
SSL decryption on Strata SASE. Okay, let's explain SSL decryption on Strata SASE. Imagine internet traffic is like mail being delivered. Some of this mail is put in special sealed envelopes that are encrypted, scrambled, using SSL or TLS technology. This is good because it keeps your private messages safe from snoopers. However, sometimes dangerous things, like viruses or malware, which are threats, can also be hidden inside these sealed, encrypted envelopes. A standard security scanner can see the envelope but cannot look inside to check for these hidden dangers. This creates a blind spot where threats can sneak through your security unnoticed. This is where SSL decryption on Palo Alto Networks, Strata firewalls, and SASE cloud security comes in. Decryption means temporarily opening these encrypted envelopes, unscrambling the traffic. Why is this essential? It's essential because it allows the security device, the Strata firewall or the SASE cloud service, to fully inspect the contents of the traffic that was hidden inside the encryption. It can now check for threats like malware, attempts to break into your systems, or other malicious activities that are trying to use encryption to hide. Once the security inspection is complete and the traffic is found to be safe, it is then sealed up again, re-encrypted, before being sent to its final destination. If threats are found, the security product stops the traffic immediately. So, SSL decryption on Strata SASE is a critical process that removes the security blind spot created by encrypted traffic, ensuring that your security tools can see and stop threats that would otherwise be hidden, protecting your network and users effectively. Encrypts traffic hides threats, malware, exploits, from security inspection. Imagine you are sending a letter, but instead of putting it in a clear envelope, you put it in a strong, locked box. This locked box is like encrypted internet traffic. Encryption uses secret codes to scramble the information inside, so only the person meant to receive it can unlock and read it. Now, think of a security guard whose job is to check all the mail going in and out of a building for dangerous items, like bombs or harmful substances. This security guard is like your firewall or security device. Its job is to inspect internet traffic for threats. Threats are bad things that can harm your computers or steal your information. Examples include malware. This is software designed to damage or disable computers, like viruses or ransomware. Exploits. These are ways attackers take advantage of weaknesses in software or systems to break in. When traffic is encrypted, like the locked box, your security guard, the firewall, cannot see what's inside. It sees the locked box arriving, but it cannot open it to check for the dangerous items, malware or exploits. For example, maybe someone is trying to download a harmful virus from a website. If that download happens over an encrypted connection, like visiting a website with HTTPS in the address, the virus is hidden inside the encrypted data. Your firewall sees the encrypted connection and allows the data to pass because it looks like legitimate traffic, but it cannot see the virus hidden inside the locked box. So, the encryption that is good for privacy also creates a problem for security. It effectively hides these bad things from the very tools designed to find and stop them. The security inspection process, which needs to look at the actual data, is blind when the data is encrypted. Allows the firewall to identify applications and enforce security policies on encrypted connections, SSL, TLS. Firewalls are like traffic police for your network. They have rules about which types of internet traffic are allowed and which are not. For example, a rule might say, allow people to use web browsers, but block people from using file-sharing programs. To enforce these rules, the firewall needs to know exactly what kind of traffic is passing through. Is it web browsing? Is it a video call? Is it a file download? However, most internet traffic today is encrypted using SSL or TLS, like when you see HTTPS in a website address. This encryption is like putting the traffic inside a sealed container. The firewall sees the sealed container passing by, but it cannot see what's inside. It doesn't know if the traffic in the container is a harmless web page or something that should be blocked, like a prohibited file-sharing application trying to connect. Without being able to see inside the sealed container, without decryption, the firewall cannot identify the specific application being used. If it doesn't know the application, it cannot apply the correct rule or security policy. It wouldn't know if it should allow the traffic because it's approved web browsing, or block it because it's unapproved file sharing. When the encrypted traffic is decrypted, the firewall can finally open the container. It can then examine the data inside and figure out exactly which application is generating that traffic. For instance, it can see its web traffic going to a social media site or file sharing traffic trying to connect. Once the firewall identifies the application, it can then look at its list of rules, its security policies, and apply the correct one for that specific application. This allows the firewall to effectively control what applications are used on the network, even when the traffic is encrypted. SSL Forward Proxy, outbound. Okay, let's talk about SSL Forward Proxy, outbound. This is a way your security device, like a firewall, handles encrypted traffic when people inside your network are trying to connect to websites or services on the internet. This is outbound traffic. Think of the firewall as a helpful assistant standing between you, the user, and the website you want to visit. When you try to go to a secure website, one that uses HTTPS, like your online bank or a shopping site, your computer wants to create a secure, encrypted connection directly to that website. With SSL Forward Proxy, the firewall steps in. Instead of letting your computer talk directly to the website with one encrypted connection, the firewall does something different. 1. It receives your request. Your computer says, "I want to talk to example.com securely." 2. It creates its own secure connection to the website. The firewall talks to example.com on your behalf, establishing a secure, encrypted connection between itself and the website. 3. It creates a separate secure connection back to you. At the same time, the firewall creates another secure, encrypted connection between itself and your computer. So, you have two separate secure connections, with the firewall in the middle. The firewall acts as a proxy, or stand-in. Here's the clever part about certificates. When your computer connects to a secure website, it checks the website's security certificate to make sure it's real and trusted. When the firewall creates the connection back to your computer, it doesn't just pass the original website certificate. Instead, it makes a new certificate for that website, and this new certificate is signed by a special, trusted identity that belongs to your organization or the firewall itself, called its certificate authority or CA. Your computer is set up to trust this organizational CA. So, your computer sees the firewall certificate and thinks, okay, this connection to example.com looks trusted because it's signed by our trusted CA. Because the firewall is the middleman with two separate connections, it receives the traffic from the website, can decrypt it, open the sealed box, inspect it for threats, look inside, and then re-encrypt it, put it in a new sealed box, before sending it back to your computer. It can also inspect the traffic going from your computer to the website. This allows the firewall to apply all its security checks, looking for malware, preventing data loss, identifying the exact application being used, even though the original traffic was meant to be encrypted end-to-end between your computer and the internet site. It's primarily used for outbound connections where the user is inside and connecting to something outside. The firewall acts as a trusted intermediary, establishing separate encrypted sessions with client and server. Imagine you want to send a secret letter to a friend far away. Normally, you would put the letter in an envelope, seal it, and send it directly to your friend. This is like a normal encrypted connection between your computer, the client, and a website, the server. With SSL Forward Proxy, the firewall acts as a trusted intermediary. An intermediary is someone or something that stands in the middle between two other things. In this case, the firewall stands between you, the client, and the website, the server. Why is it trusted? Your computer is set up to trust the firewall's role in handling these connections. It knows the firewall is supposed to do this job safely. Now, instead of one direct secret connection from you to the website, the firewall creates two separate secret connections. 1. Secret Connection 1. The firewall makes a secure, encrypted connection with you, the client. When you want to visit a website, your request goes securely to the firewall. 2. Secret Connection 2. The firewall then makes its own separate secure, encrypted connection with the website, the server, you wanted to visit. The firewall talks to the website on your behalf. So, the firewall is in the middle, handling two different secret conversations at the same time. It receives the secret message from you, opens it, and then puts it into a new secret message to send to the website. And it receives the secret message from the website, opens it, and puts it into a new secret message to send back to you. This setup, where the firewall is the trusted go-between with two separate encrypted sessions, is key. It allows the firewall to see the traffic between the two sessions when it's decrypted inside the firewall, without you or the website necessarily knowing or needing to change how you communicate. It dynamically generates and signs certificates for visited websites using its own certificate authority, CA. Okay. Let's explain this part of the SSL Forward Proxy process in simple terms. Think of visiting a secure website, one with HTTPS. When your computer connects, the website sends back something like a digital ID card, called a certificate. This certificate helps your computer check that the website is real and safe to connect to securely. These certificates are usually issued and approved by well-known, trusted organizations called certificate authorities, CAs. Your web browser, like Chrome or Firefox, already trusts a list of these public CAs. Now, with the firewall doing SSL Forward Proxy, remember it's acting as a trusted intermediary between you and the actual website. When you try to go to, say, banking website, https://mybank.com, your computer sends the request to the firewall. 1. The firewall connects to the real mybank.com and gets its real certificate, issued by a public CA. 2. But instead of just giving that real certificate to your computer, the firewall does something different. It makes a new certificate specifically for mybank.com on the spot. This is what dynamically generates means. It creates it right when needed. 3. Then, the firewall uses its own special digital stamp to approve and sign this newly created certificate. This special stamp belongs to the firewall's own certificate authority, its CA, which is set up within your organization. Your computer or network is configured to trust this specific organizational CA, the firewall's CA. So, when the firewall sends this new certificate for mybank.com back to your computer looks at it. It sees the certificate is for mybank.com, and it sees it signed by the organizational CA that your computer is configured to trust. Your computer then says, "Okay, I trust this connection," and establishes a secure session with the firewall. This process of the firewall creating and signing a temporary certificate for each website you visit allows it to build the necessary separate, trusted, encrypted connection with your computer, which is the first step needed before it can decrypt and inspect the traffic. Permits decryption, inspection, and re-encryption of traffic destined for external sites. Okay, let's explain this part of the SSL Forward Proxy process simply. Remember, the firewall is acting as a trusted intermediary, standing between your computer, the user, and the website you want to visit on the internet. Because the firewall has set up two separate secure connections, one with you and one with the external website, it's in a special position. When your computer sends encrypted traffic towards a website, 1. Permits decryption. The traffic first arrives at the firewall, still encrypted, like a sealed letter. Because the firewall is part of the connection it established with you, it has the necessary key to unlock this specific sealed letter. This is decryption. The firewall is allowed to open the encrypted traffic and see what's inside. The traffic is now in clear, readable form within the firewall. 2. Permits inspection. Now that the traffic is no longer hidden by encryption, the firewall can inspect it. This means it can examine the actual data content. It looks for dangerous things like malware, viruses, attempts to hack the system, exploits, sensitive information that shouldn't be leaving the network, and it confirms what specific application is being used, like web browsing, not forbidden file sharing. This is where the firewall applies its security checks that couldn't happen when the traffic was hidden. 3. Permits re-encryption. After inspecting the traffic and making sure it's safe according to the rules, the firewall doesn't send the now readable data out to the internet without protection. It takes the cleaned, inspected traffic and puts it into a new sealed letter, using the key from the separate secure connection it established with the external website. This is re-encryption, scrambling the traffic again so it's private and secure for its journey from the firewall to the final destination. This entire sequence, decrypt, inspect, re-encrypt, happens for data traveling outward from your network towards sites on the internet, enabling the firewall to enforce security rules and detect threats within traffic that would otherwise be invisible. No decrypt policy. Okay, let's talk about something called a no decrypt policy. We've discussed that decrypting encrypted traffic, like HTTPS, is important for the firewall to see threats and identify applications. But sometimes, for specific reasons, you tell the firewall not to decrypt certain traffic. This is what a no decrypt policy does. It's a rule that says, for this specific type of internet connection, do not open the encrypted box. Why would you make such a rule? There are two main reasons. 1. Sensitive data, privacy. Some types of traffic contain very private or sensitive information. Think about connecting to your online bank account, your healthcare provider's website, or perhaps a government portal. These connections often have strict privacy requirements. Even though the firewall could decrypt and inspect this traffic, the organization might decide not to protect user privacy and comply with regulations. You set up a no decrypt policy for these specific websites or categories of traffic to ensure the firewall always leaves these connections encrypted, keeping the sensitive data hidden from inspection by the firewall. For example, you might set a policy that says, never decrypt traffic going to websites categorized as healthcare or financial services. 2. Technical reasons. Sometimes, the way a secure connection is set up makes it technically difficult or impossible for the firewall to decrypt it properly without breaking the connection. One example is mutual authentication, where both your computer and the server verify each other's identity in a special way during the connection setup. The firewall trying to step in and decrypt could interfere with this process, causing the connection to fail. In these technical situations, you also create a no decrypt policy to allow the connection to work without interruption. So, while decryption is a powerful security tool, a no decrypt policy is equally important. It gives you control to decide which encrypted traffic should not be inspected, balancing security inspection needs with privacy requirements and technical compatibility. When a policy is set to no decrypt for certain traffic, the firewall lets that encrypted traffic pass through without opening it, meaning it cannot inspect it for threats or identify the application in detail for that specific connection. Configured to specifically exclude certain traffic from decryption. Okay, let's focus on the idea of configured to specifically exclude certain traffic from decryption. We know that the firewall can usually decrypt encrypted traffic, like the sealed boxes, so it can inspect them for bad things. But sometimes, the people managing the network, the administrators, decide that some traffic should not be decrypted. Configured means the administrators set up rules or settings on the firewall. They tell the firewall exactly what to do. To specifically exclude certain traffic means they make a special list or rule for only some of the encrypted traffic. It's not for all traffic, just particular kinds that they choose. Think of the firewall again as the security guard checking mail. Usually, the guard is allowed to open all sealed boxes, decrypt all traffic. But the people in charge give the guard a special instruction. For any box coming from or going to list of specific places, types of mail, do not open it. Just let it pass through sealed. The certain traffic they exclude could be, for example, traffic going to specific bank websites, traffic going to hospital or healthcare websites, traffic involving very sensitive company secrets, traffic that uses a very special technical way of connecting that decryption might break. So, configuring the firewall to specifically exclude certain traffic from decryption means setting up a rule A no decrypt policy that tells the firewall, when you see traffic matching this description, like going to a bank website, do not perform decryption on it. The firewall follows this instruction and leaves those particular encrypted connections completely untouched and private, even though it might be decrypting other traffic at the same time. Typically used for sensitive data, e.g., healthcare, finance, or connections with technical decryption challenges, e.g., mutual authentication. Okay, let's explain why we often use a no decrypt policy for certain internet traffic. Remember that a no decrypt policy tells the firewall not to open and look inside encrypted traffic, the sealed boxes. We typically use this policy for two main kinds of situations. 1. Sensitive data. Some information is very private and important. For example, when you connect to your online bank to manage your money, or when a doctor's office connects to a healthcare system to check patient records, the information being sent is extremely sensitive. It includes personal financial details or private health information. Even though decrypting would allow the firewall to check for security threats hidden in this traffic, many organizations decide that the privacy of this sensitive data is so important that they choose not to decrypt it. The policy protects this private information by ensuring it stays encrypted from start to finish. 2. Technical decryption challenges. Sometimes, the way an encrypted connection is set up makes it difficult or impossible for the firewall to decrypt it without causing problems. A common example is something called mutual authentication. This is when both the user's computer and the server they are connecting to check each other's identity very strictly at the beginning of the connection. If the firewall tries to step in and decrypt, it can interfere with this special identity checking process. It's like trying to listen in on a secret handshake. You might mess up the handshake, and the connection fails completely. To avoid breaking these specific types of connections, a no decrypt policy is used. It allows the technical handshake to happen smoothly by telling the firewall to just let that specific traffic pass through without trying to decrypt it. So, these are the main reasons why you would tell the firewall not to decrypt certain traffic, either to protect very sensitive private information or because decrypting would technically break the connection.